So what is the fundamental theorem of algebra? If it's called the fundamental theorem, it's probably pretty important, and it seems somewhat weird that you would be learning it in Algebra 2 as opposed to in Algebra 1. I know when I played sports or anything like that, you learn the fundamentals early on and not like when you're almost done with your high school algebra career. So that seems a little bit backwards. What the fundamental theorem of algebra tells us is it tells us how many complex roots a polynomial equation will have. It tells us how many complex zeros a polynomial function will have. It states something like this. For a polynomial function of degree n, where n is greater than or equal to 1, that polynomial function will have n complex roots. So the degree is equal to the number of zeros of the function. The degree is equal to the number of roots of the equation. That's the main idea. Now, they certainly don't all have to be unique. We talked about situations before where maybe x minus 3 showed up as a factor 3 different times so that you would get a 0 of 3 from that factor each time it occurred. We gave that a name. We called that multiplicity. So when bringing in all the complex zeros, and dealing and counting the zeros of higher multiplicity multiple times, the fundamental theorem says the degree will be equal to the number of zeros we get. It will be equal to the number of roots that we get. So that's pretty powerful. It lets us know when we're done. If we're faced with a problem that says find all roots of the polynomial equation or find all zeros of the polynomial function, we know how many we're looking for. If the degree of the function is 5, then it will have 5 complex zeros. If the polynomial equation is an equation of degree 3, it will have 3 complex roots. Some might be real, some might be imaginary. Remember, the complex number system is this big overarching number system. It's broken down into the 2 branches, the real numbers that you've been working with most of your life, and the imaginary numbers that we've started working with here. The difference, complex numbers are of the form a plus bi, where a and b are real numbers. The real numbers are the ones where the value of b, the number in front of the I, is 0, so it doesn't exist, and we just have the real component. The imaginary numbers are the ones where the value of b is not 0, so we might have something like 3 plus 2i, so it has that imaginary piece to it. So I kind of rambled on a little bit about that. Just remember the main idea is that that degree of your equation or that degree of your function tells you how many zeros or how many roots you are looking for. That's the main idea from this section.